Okay, here is the next example. In this example, he's asking us to find ABCD parameters. So first, what we're going to do, we're going to write down the equations. The equations we have: V1 equal to AV2 minus BI2 and I1 equal to CV2 minus DI2. So as mentioned, we can find A and C together by using the same circuit. So I'm finding A equal to V1 over V2 when I2 equal to 0 and C equal to I1 over V2 when I2 equal to 0. So I'm going to use the same circuit to find these two parameters, making I2 equal to 0. Now I have kind of two sources. One is V1 is one source and 4ix is a current dependent current source. So I have to solve this by using either mesh analysis, nodal analysis, or nodal analysis. So here I'm taking the voltage here as V2 because there is no voltage drop here. So I'm using the nodal analysis. Now I'm going to apply KCL at V2. So I'm taking IA is coming in, 4ix is also coming in, and here it's 0 ampere. So at V2 apply KCL. If you apply KCL, it's KCL IA plus 4ix equal to 0. So it's IA is nothing but Vx minus V2 over 1 plus 4ix. Ix is nothing but Vx minus 0, Vx minus 0 over 2. That's our Ix. So Ix I can replace Ix with Vx over 2. So I'm replacing the Ix here with Vx over 2. So after simplify this equation, I ended up with Vx equal to V2 over 3. Now I'm going to apply KVL at Vx. So at Vx, I can see I1 is coming in, Ix is going out, and Ia is going out. So I1 equal to Ix plus Ia. I1 is coming in, Ix plus Ia. So my apology, it must be KCL. Okay, apply KCL. So KCL is nothing but currents coming in must be equals to currents going out. So I1 equal to Ix plus Ia. So I1 is V1 minus Vx over 1. I1 is this voltage minus this voltage, V1 minus Vx over 1, that is I1. Ix is Vx over 2, Ia is Vx minus Va over 1. Okay, so this is the equation after substitution. So I'm going to multiply with 2 to eliminate the denominator. So I will end up with 2V1 minus 2Vx equal to Vx plus 2Va minus 2V2. So 2V1 equal to 5Vx minus 2V2. So to eliminate the denominator, I'm going to multiply with 3. I end up with 6V1 equal to minus V2. So A equal to V1 over V2, which is minus 1 over 6. This is our A. Now to find C, I need to find C equal to, so according to the given equation, C equal to I1 over V2. C equal to I1 over V2 when I2 equal to 0. I2 equal to 0. So all I need to do is I need to find the relation between V2 and I1. So from the KCL at Vx, so I'm going to use this equation, KCL at Vx. I have I1 equal to Ix plus Ia. So what I'm going to do, I'm going to keep I1 as it is, since I need the relation between I1 and V2. I1 Ix, I'm going to write this as Vx over 2. So it is from here, that is Ix over 2, Vx over 2. Ia, I can say Vx minus V2 over 1. Now I'm going to multiply this with 2 to eliminate the denominator. So I end up with 2I1 equal to Vx plus 2Vx minus 2V2. Okay, so it is 3Vx minus 2V2. Now I can substitute Vx equal to, V2 by 3. So I have 2I1 equal to 3 times Vx is nothing but v2 over 3 minus 2 v2, 3 get cancelled, so 2i1 equal to minus 2 minus 1 v2. So basically it's v2 minus 2 v2, so we'll end up with minus v2. So c equal to I1 over v2, this equal to minus 1 by 2, which is minus 0.5. Okay, this is Simon. C has a unit of Simon. Okay, now I found C, I found A. Now we need to find the remaining two parameters. To find the remaining two parameters, those are short circuit parameters. So for the short circuit parameters, here it says a v2 equals 0, so we're going to short circuit this. So let me draw the diagram down here. Now we're going to find the remaining two parameters, B and D. Here v2 equal to 0, so we're going to short circuit this. So when we short circuit this, v2 equal to 0. Now still we have two sources. V1 has one source and this is dependent source. I'm going to use either mesh analysis or nodal analysis. So I'm going to ground this here. So once I ground this, what is the voltage at this point? The voltage at that point must be 0. Okay. As I mentioned, finding D first is easy, better option. So first we'll find D parameter. So all I need relation between I1 and I2. I know I2 is coming in, 4ix is coming in, and let me take this IA coming in. So let me take this value V2 at voltage at that node. I'm taking that as V2. At V2, I know that value is 0. Apply KCL. Okay, I'm applying KCL, Kirchhoff's current law. So all currents are coming in IA plus 4ix plus I2 equal to 0. All I need to write an equation, relation between IA, Ix and I2. So can I say IA is nothing but, let me take the voltage here as similar, Vx over 2, my apology, it's Vx minus 0 over 1 plus 4 Ix, I can say Ix equal to Vx over 2, 4 times Vx over 2 plus I2. I'm going to keep I2 as it is, equal to 0. So I have 2 Vx, so 3 Vx equal to minus I2. And now I have an equation here. Now I need to come up with another equation. At Vx, apply KCL. If I apply KCL at Vx, I1 equal to Ix plus Ia. I'm going to, since I need relation between I1 and I2, I'm going to leave the I1 as it is. Ix, can I write this as Vx over 2 plus Ia is also Vx minus 0 over 1. So I'll end up with Vx by 2 plus Vx I1. So I1 equal to, can I write this as 3 by 2 Vx. Okay, now from this equation I'm going to say Vx equal to minus I2 over 3. So I'm going to replace that here. I'm going to substitute this here. So I1 equal to 3 by 2 times minus I2 by 3. These two get cancelled out. Minus I2 by 2. I1 equal to minus I2 by 2. So D is nothing but minus I1 over I2. That will be plus 0.5. There is no unit for that. Now I have D. Now I'm going to find B. B equal to I have equation b equal to minus v1 over I2. So I need relation between v1 and I2. So from the same circuit. Okay, so I'm going to use, so I already have this equation, okay, from the previous, and I also have another equation here. Another equation there. So I'm going to keep Ix as it is. Okay, sorry, I don't need to keep Ix as it is. I want to write everything in terms of V1 and Vx. So I know this I1 from here. I1 is nothing but, can I write V1 minus Vx over 1? So here is I1. So I1 is this voltage minus this voltage divided by the resistor. So I1 equal to V1 minus Vx over 1. So if I substitute it here to find B, so it is V1 minus Vx equal to 3 by 2 Vx. So V1 equal to 3 by 2 plus 1 Vx, which is going to be 5 by 2 Vx. So V1 equal to 5 by 2 Vx. Now to find B equal to minus V1 over I2. So I'm going to substitute this Vx value right there. V1 equal to 5 by 2 minus I2 over 3. Okay, so V1 equal to 5 by 6 minus, so if I bring I2 on negative other side, B is nothing but 5 by 6. That's our B. So I found all other quantities. So ABCD parameters are, I have A, B, C, D. So far I have, this is 0.5, sorry, 5 by 6, B is 5 by 6, D is 0.5, and I have C as minus 0.5 and A as minus 1 by 6. Minus 1 by 6, this is minus 1 by 2.5. Okay, that's all. Thank you very much.